A plain LLM is great when the problem is mainly thinking, explaining, summarizing, rewriting, or brainstorming, or even coding or reasoning from information already in the prompt. Reg is for when the problem is not just thinking but needing the right external knowledge at the right time. If the answer has come from a specific PDF, policy, handbook, contract, or internal document, then a plain LLM by itself is not enough. So simple rule is this: if the task is mainly intelligence, we use LLM. If the task is intelligence grounded in specific source material, we use reg. LLM means answer from what the model already knows. Reg means retrieve first and then answer. So there are few example where LLM is enough, right? So LLM is enough for summarizing text already pasted in the prompt, rewriting an email, generating code from requirement, explaining concepts like APIs, recursion, or database, or brainstorming ideas. And where reg is better fit is answering question about your own knowledge on PDF, querying a company handbook, support boards grounded in official documents, legal, policy, and compliance documents, or even internal knowledge base. The reg does not replace the LLM. The LLM still does the reasoning and answer generation. Reg just give it the right evidence first. So in this project, the model is not supposed to guess what is in our PDF. Our job is to build the retrieval system that finds the right parts. By the end of this live session, you will understand the exact pipeline. So load PDF, the pipeline will have load PDF, and then we extract the text, we chunk the text, we create embeddings. Embeddings are basically numbers of array, right? So array of float. Then we store those data in FAISS database. User can ask questions. Question when the user asks the question, we also have to embed the question as well. And based on this embedding and the data we have in the embedding, we retrieve closest chunk and we then generate grounded answers. So that's it. Today we are not building a generic chatbot. We are building a chatbot that answers specific PDF that is important. The important idea is that the language model does not directly know the PDF. We first turn the PDF into searchable pieces, retrieve the relevant piece for question, and only then ask the model to answer. So if you remember only one sentence from this session, remember this: reg means retrieve first and generate second. For a real life analogy, let me give you an example. So a normal chatbot is a student walking into a closed book exam. They only know what they memorized during training. Anything newer or anything private they will either miss entirely or just make something up, and that's what we call hallucination. A reg chatbot gets to the exam open book. Before answering it, it flips to the relevant pages and read it first. That's genuinely whole idea. Everything we write, everything we're gonna implement is plumbing to make flip to the right page. That happens actually in the code. So let's dive into the coding. Yep. So uh, we are creating this program in Jupyter Notebook, right? So in Jupyter Notebook, you have to select a kernel. From here, you can have your kernel installed, or you can use Jupyter Notebook in your computer to have another kernel or separate kernel for this one. So first of all, we gonna install all the dependency, all the libraries we need in the project. So yeah, pip install -q. So just for your reference, apostrophe is not gonna work in Make. In Make, you have to write the percent sign instead. So in .NET, in Windows, we're gonna use apostrophe pip install -q. Then the apostrophe means we are running a shell command from inside Jupyter, and -q means we will run it in quiet mode. These are infrastructure dependency, not the reg logic itself, right? So yeah, q we're gonna use PyPDF. PyPDF we generally use it to read the PDF basically, right? So I'll explain this later. Let me just install the libraries quickly. PyPDF we need FAISS CPU, we need Ollama and IPY widgets. Okay, so that's done. The dependency is there. We are gonna dive into another code section where we're gonna import all the dependencies we have installed or which we will need. So the first one we're gonna use from IO import bytes IO. So what's the use of bytes IO? The upload widget gives us bytes in the memory, not a file path on disk. Bytes I have wrapped those bytes so another library can treat them like a file, right? So we use it for that. And then another thing is from PyPDF, if import PDF reader, right? PDFs are not plain text file. PDF reader knows how to parse the PDF format and extract text page by page. That's why we're gonna use PDF reader. And then we're gonna import IPY WID widgets as widgets. This is just for interactivity in the notebook. It lets us create an upload button or text input without hard coding file paths or using inputs, right? So that's there. Then we're gonna import Ollama. So we'll use Ollama for two different jobs, embedding and text generation. Those are related but not identical tasks. Another one we're gonna import is import FAISS. And FAISS is our vector index. It will store chunk embeddings and let us find the nearest one later. And then we gonna import numpy s and p. FAISS expects numeric arrays in numpy compatible format, especially in float 32. So that's why we have that. Then we define the model name, embedding model name. So embed underscore model equal to and3 embedding 8 billion. And the chat model we're gonna use is we're gonna use Quen3 4 billion, or let's use another model, that is Llama LLMA 3.2 3 billion, right? So this model I'm using from Ollama, and you can install that Ollama on your system. If you want to run local version of LLM, you need to check which model can support your operating system. I've tested the same with this MacBook M4 Pro and it worked for me, but you can check which computer you are having. It can differ based on the system you have, right? So we have two models now. One is Quen3 embedding 8 billion, that is for embedding model, and then chat model we have Llama 3.2 3 billion. I'm separating the embedding model from the chat model because they serve different roles. One map text into vectors, the other writes languages. The chunk the user questions must be embedded with the same embedding model, otherwise their vector live in different spaces and similarity search becomes meaningful, right? So we gonna embed the knowledge base, that is the knowledge we extract from PDF, and then we embed them with this. But to retrieve the answer, we also embed the question. We will also embed the question. Okay, so this code is there, and then I'm gonna create another section to actually load the PDF file, right? So def load and chunk. So we're gonna load and chunk the file together. So we're gonna have PDF bytes from the file, and then we're gonna use chunk size. Chunk size we're gonna have 1000, and then we have overlap that will be 150. Before writing this, I'm gonna give you one definition. Let's say the first real engineering problem in Drake is not the model, it's document processing. We need to convert one big document into smaller searchable units. This function takes raw PDF bytes and return the list of the chunk, right? So that's there, and then we gonna read the file. So reader equal to, we're gonna use PDF reader that we have defined earlier, PDF reader, and then we're gonna bytes IO PDF underscore bytes, right? I'm opening the uploaded file directly from the memory, no disk path is needed. Okay, so that's there. Now we gonna read full text equal to we're gonna define it as blank, and then we gonna read 4 page in reader.pages. So this reader, this PDF reader will gonna give us multiple pages of the PDF. So if your PDF is, let's say, having 100 pages, it will load all 100 pages in the reader as an array called reader.pages, and then we loop through this, and then we'll load all the text into the full text to start the chunking, right? So full underscore text plus equal to page dot extract text. This is the function to extract the text from the PDF and PDF page actually, and then we're gonna append the relation in the end, so it always renders in the next line. It will not merge into the same paragraph, right? Okay, so this there we have PDF that been converted into full text, and we have the full text in this variable, right? So then we're gonna declare another variable that called chunks, and we're gonna define the starting point, that is start equal to 0. Now we're gonna loop through the length of the full text till we reach the end, right? So while start is less than length of full underscore text, right? We're gonna define the end point of this thing. So the very first thing is start, because we are starting as of now with 0, but as the loop goes, we need to change the value of the start, and we start will change the value of end as well. So start plus the chunk size, and the chunk size we have defined earlier in while creating the function, right? So this there, and now we create a chunk equal to full text, and we're gonna do the split start to end, right? So your start for the first very first loop, your start will be 0, and your end will be start plus the chunk size, that is 1000. So your chunk will be 0 to 1000, right? And then we append the array of the chunks dot append, and we gonna append chunk, right? Now we gonna reset the start variable start point to the end, because we have already read 1000 characters of the text, so we don't want to read it again. So we start the next chunk from that 1000 only. But there is a condition. We have this overlap variable defined here. So I've defined this is as 150. What overlap does is, when you create the chunk, you also have to create something related to the previous chunk. So if you put it directly, they will not become related, and your program will start giving the hallucinated response. When you have this overlap, meaning when you took the 1000 characters from the last chunk, there will be 150 character that will be written in the very first of the next chunk, so that they can become related, right? So that's the we have created chunk. We have to return the chunks, right? So why chunking exists? If you want to know why we are chunking it, why chunking exists? If I embed the whole PDF as one vector, retrieval become two cores. A question about refund, deadline, or definition should map a specific region of the document, not the entire document at once. And for overlap protects meaning at the chunk boundaries. If the sentence starts near the end of one chunk and it finishes in the next, overlap helps both chunks preserve that idea. But there are some trade-off, which is larger chunk preserve more context. Smaller chunks are more precise for retrieval, and overlap improve robustness but increases redundancy. At the end of this function, we still do not have AI. We just have a list of strings, but those strings are now the basic searchable units for the document. So we're gonna create another block to upload file. So uploader equal to we're gonna use the widgets that we have defined. So this is Jupyter Notebook widget that will create some elements on the screen or in the notebook file to upload files or text. So upload. Yeah. No, we don't wanna use. Okay, I've used wrong block. Shit, sorry. So uploader equal to widgets dot file upload, and yeah, we're gonna accept only PDF as of now, as we want to narrow down to the allowed file types only, right? So PDF multipart equal to false, multiple equal to false keeps the demo very simple. We don't want multiple files, right? Description equal to upload PDF. Okay, and now we need to display this, so we're going to use display function and then uploader. Yeah, that's all. Display is what actually renders the widget on the notebook file. We will see when we run this. Okay, so the notebook now has browser side upload control. The important point is that file content will come in to the Python as byte. Right now, it comes to the next code block. So we're gonna read the uploaded file now, and we're gonna produce the chunks now. So uploaded underscore files equal to uploader dot value. So all the uploaded files through this will come in the uploaded files. If not uploaded files, then we're gonna throw an exception, right? So the raise value error and no file uploaded. And then another condition is if is instance uploaded underscore files is dictionary, then we're gonna use this function as uploaded file equal to next iteration and uploaded files dot values. Okay, so that's it. And we're gonna use the PDF name uploaded file. We're gonna have metadata, and we're gonna extract the name from the metadata. Okay, so if this instance is not dictionary, then what? Then we get the file equal to uploaded underscore files, and we get the 0th rank file or 0th variable in the array, and PDF underscore name also we're gonna use uploaded underscore file, and then we're gonna get the name. Okay, cool. So this is done. Now we need to convert the file into the bytes. So PDF underscore bytes equal to bytes uploaded underscore file, and from uploaded file we're gonna need content. Okay, that's there. We're gonna also print the file name, so we will make sure that we have the file, right? So received PDF underscore name. Okay, so that's there. Now we need to chunk the PDF. We read the PDF, we stored in the bytes. Now we gonna chunk it. So for chunking we will call this function that we have created earlier, right? So PDF underscore chunks equal to load underscore and underscore chunk underscore PDF. No, not PDF. That's the only thing. Okay, so here we gonna pass what the PDF file that we have read in the byte, PDF underscore bytes. Now we will have PDF all the chunks in the PDF. Now we gonna print the length of the split PDF chunks, and then we gonna also print some first of chunk previews, right? So print your PDF was split into length of PDF underscore chunks, right? So this gonna give the size of the chunk, and then we're gonna print the preview to PDF chunks of the 0 at the length of 300 characters, right? Okay, so the upload widget has changed the shape across versions. So this code handles both frame. So one is this and another one is this, right? PDF bytes. Okay, so PDF bytes, it will normalize the uploaded content into plain Python bytes, right? And this is the moment the raw file become a list of chunks. The most important object in our memory is now PDF chunks. It is just a Python list of a string. Every letter AI step in is built on top of this list. Now we're gonna implement another function to build the embedding. So here it is. Yeah. So in embedding we're gonna need time library also. So that is defined def embed underscore text, where we'll have input of text which underscore size that will be default to 8 and retries. So if something fails it will retry a few times. I'm giving it 3. Okay, so I'm gonna define a variable called all embeddings that will be empty array, and I'm gonna loop it through from I in range of 0 comma length of text to the batch underscore size. Right, now batch, I'm gonna create some batches. So batch equal to text I is to I plus batch size, and for attempt in range retries try response equal to, now we're gonna use the Ollama model, right? So and specifically Ollama embedding model, Ollama dot embed. The model name we're gonna use is the model name we defined earlier, embedding model mbd underscore model. So that is there. The another thing is we're gonna use input equal to, and input we gonna pass the batch we have just created, and options we gonna pass the context window. So the context window will be number of CTX. Context window will be 4096, as we are doing it on very basic machine, or on our computer we will not be able to handle large context with the size of 16 GB GPU, right? So that's there. And now we're gonna append the all embedding dot extend a response of embeddings. Okay, and then we break if some exception occurs. So we do except exception if the attempt equal to retries -1, then raise, else it will see to 2 seconds and it will continue. Okay, so as the loop is continue and the loop is done, and we have all the embeddings, we will return the embeddings, right? So that is there. This function, let me explain you this function in detail, right? This function takes a list of a string and return a list of embeddings, where each embedding is a list of numbers. We have then batch loop. So I'm batching request because sending too much text at once can exceed local model limits, right? So that's why the batching is needed. Then we have the tree retry logic, right? Local model server can briefly fail while models are loading, so retries makes the demo more reliable. And about this, I'm extending the output list because each batch returns multiple embeddings, one per input string. This function is not bridge between the document as readable text and the document is a searchable vectors. Now as we have the chunks of the embedding, we need to create some embeddings, and we need to build it in FAISS, right? So we create another code block and we'll have to write the code for it, right? So we have the chunk text now. Now we are creating the vector equivalents and loading them into searchable index, right? So chunk embeddings equal to we need to call the function that we have created just now, this one, embedding embed underscore text, and we need to pass PDF chunks in it, right? Then we gonna change the value of embeddings to the np.array chunk things dot is type float 32 because FAISS works on the numpy array on the float 32 specific type. This line matters a lot. FAISS expects float 32 and forgetting that is a common bug, right? So as we have that, we now need dimension, right? So dimension is the embedding size. FAISS needs to know how many numbers lives in each vector, so we need to have dimension equal to chunk underscore embedding dot shape 1. Okay, now we need to create index flight. So this is simplest FAISS index. It uses Euclidean distance and does exact nearest neighbor search. So to do that, we need to define index equal to FAISS dot index flight L2, and then we have to pass dimension in it. Okay, so let me repeat again. This is the simplest FAISS index. It uses Euclidean distance and does exact nearest neighbor search, right? So in the index, we're gonna add it to chunk underscore embeddings, right? Index.add chunk embeddings, this loads all the chunks vectors into FAISS so they can be searched later. At this point, we have two parallel structure in memory. One is PDF chunks, which stores human readable text, and the index, which store vector representation of all the chunks. FAISS does not store meaning as words. It stores position in the vector space. We still keep PDF chunks because after retrieval, we need the original text back, right? So now we need to build the retrieval part. We will have another code block, and in here we're gonna write def retrieve relevant underscore chunks, and that we're gonna pass the cushion and top underscore k equal to 8, right? So this is the retrieval step in rig. We take the user's cushion, turn it into vector, and ask which stored chunk vector are closest, right? So cushion, as I told you, we also have to embed the cushion, so we are doing that. We are using the method that we have created earlier to embed the text, and we're gonna pass the list of cushion. We are not creating chunks of the cushion, we are passing the cushion as it is in the array, because our main method expects text in the array. So that's why we have done that, right? So if in simpler terms, if you want to hear, even one question is prepped in a list because the helper function expects a list of strings, right? So helper function is here, right? Okay, so that's there. Now we need to get distances and indices from the index dot search np dot array cushions underscore embedding a dot s type float 32. This is done because again your FAISS wants the detail in float 32 type, right? So that's a the cushion must be embedded with the same model as the chunks. That one thing to keep in mind, sorry. So this this cushion must be embedded with the same model as the chunk. That keeps everything in the same vector space. If you use different model for different chunking, then it will go fail. Index.search FAISS gives us two things: the distance and the indices of the nearest stored vector, right? So that's there. Now we need to find relevant chunks. Also, we in this function we also have to pass the top underscore k, right? Now we have this. We now have to find the relevant chunk. Relevant underscore chunks equal to from PDF chunks, PDF underscore chunks I for I in indices 0 Okay, so not okay, we need array of it, so we need to wrap it in the blocks. Okay, so we get the distance and indices from the FAISS, right? But FAISS only knows positions, not the document prose. So I use the returned indices to look up the actual chunks text from PDF chunks, and this function returns the plain text chunks, not the vector. Retrieval is finished when we have relevant in the evidence back in the human readable form. So we're gonna return relay underscore chunks. Okay, so this is there. Now we need to test the retrieval, right? So we create another block, and we're gonna type the question, and then we're gonna find the relevant chunks for that question. So text underscore question equal to what is this document about, and it will give us some chunks. So found chunks equal to we gonna call this method, so retrieve chunks, and in that we gonna pass our text question, or we should name it as test question, let's say, underscore question. Okay, now this will print top length of found underscore chunks, and it will also print relevant chunks for test question. Now we're gonna print all the chunks, some character of all the chunks, right? So for I comma chunk in red found underscore chunk comma 1. So we're gonna enumerate it, and we're gonna print if station chunk I and station chunk, and then a split of 200 characters only. Now before I involve in the chat model, I want to inspect retrieval quality directly. This is good debugging habit in reg. If retrieval is bad, generation will also be bad. So a lot of reg problems are actually retrieval problems wearing a generation costume, right? Okay, so this is there. Now we need to build the final reg function that is for when you have to ask the question, that functions will be used, right? So we're gonna have another code block, and in this code block we're gonna define def ask underscore pdf. So this will be a function where you're gonna pass your question, and then top underscore k, that is 8, right? So we're gonna find the relevant chunks of our question, right? So relevant underscore chunks equal to, we can just copy the function name relevant chunks and pass the question and the top k, right? Now we need to create context, right? So context equal to, we gonna have new line. So why do we have that? Let me explain you after writing the code, right? So join relevant underscore chunks. So we're gonna join all the relevant chunks with the slash n. So after every chunk we will have this line, so that will identify that this chunk is different from the other one. So we're gonna build the context. Now we're gonna need a system prompt, right? So prompt equal to, we're gonna write some of the text here, right? So let's say you are answering questions about a document using say I don't have information in this document if the excerpts contain nothing relevant to the question. So this is when we when this is when there's nothing find in the relevant chunks, so it will return I don't have any information on this, right? So this is it. Now along with the prompt we gonna have excerpts, in that we gonna pass the context that we have defined earlier. We're gonna define question also, so question, and then we're gonna define answer, because we are expecting that actually. Okay, so the system prompt is defined. Now we need to call the Ollama response chat model basically. So response equal to Ollama.chat, model equal to chat underscore model, message equal to, we have to pass a role, so role equal to user, and content equal to prompt. Okay, and options equal to number of prediction we want to have. So this will be the size of the token that will be produced, and then we have the context length, so number underscore ctx, this is our context length, which will be 1892, and then we're gonna return the responses. From response we have this message object, and from message we're gonna return content. Okay, so in this we have glued retrieval and generation together. This is the point where the model finally sees the document evidence. First I fetch the relevant chunks. Without that this would just be a normal chat call. I join the chunks into one context block with separators so that the model can see them as a distinct excerpts. Next, the prompt is doing behavioral control. I'm explicitly telling the model to synthesize across excerpts and only admit missing information when evidence truly is absent. And with the Ollama chat, this is the generation step. The chat model reads the augmented prompts and write a grounded answer. These are the practical controls, right? So number prediction limits the answer length, and number of context defines how much total prompt and output the model can handle. The model is still not searching the PDF itself. We searched first, right? We found the relevant chunks, then we gave it to the model only that parts that matters, and yep, voila, we have generated the response, right? Now we need to test the full pipeline, right? So we'll create another function that will answer the last question we have asked, right? So ask underscore PDF, and the question was, what is this document about? It will answer the question, and so we just need to print the question, print the answer, right? So this is also done. Now we will need a final block where we will have a text box that we can interact to and get the answer, right? So question underscore box equal to chats dot text. We're gonna need a placeholder, ask something, okay, and layout will be widgets dot layout, and width is gonna be, let's say, 70%. We're gonna need a comma in the end, comma, and then we're gonna do continuous equal to false, right? and then we're gonna need a ask button, where it's a button that have a description of ask, and button underscore style will be primary. And then we're gonna need output window, so that's there, chat output, and dot output. Also here we need be capital put. No, we need a function to handle the question, def handle questions, right? And in that we're gonna write equal to question works dot value dot strip will remove all the white spaces before and after the text, and if question not question, then it will return the answer, else it will go for question box dot value. We're gonna make it empty because we already asked the question. With chat underscore output, we're gonna print the question first, and then we're gonna have the answer from our method that we have created earlier, ask pdf and question, right? And then we will print the answer. Underscore model, which model we have used to can for answer, right? And that will end with a slash n for a new line. Perfect. So that's it. Now we will call the function ask button dot. We're gonna read the events basically on click handle question and question underscore box dot observe handle underscore question, and the name will be value, and then we have display widgets dot h box, that we're gonna pass the array of question underscore box and ask underscore button, and we're gonna print the chat underscore output. So this is the end of the code we're gonna write. We are writing here, and let me just explain the last function that I wrote. So widget.text, this is the question input box that we have created. Continuous update false. This prevents the handler from firing on every keystroke, which is dot output is to handle the output. This is where the chat transcript will be printed, and this handle question, this is the event handler that reads the question, validates it, call the reg pipeline, and print the answer. One line handles click, so one line handles button click, and another one handles enter from the text box. And now the notebooks behave like mini document chatbot, but importantly, every part of the pipeline is still visible and teachable. The document is no longer a big file, it is now a list of searchable. The text now has two separate representations, human repeatable string and the vector position, right? Okay, so this is it. We have built a direct chatbot from first principle. We loaded a PDF, we extracted the chunks, its text, converted into the embeddings and indexed them FAISS, embedded the user's question, retrieved the nearest chunks, and passed those chunks to a model to answer from the evidence. Right, so let's run the code first one by one, and let's see what happens. The very first thing, you have to select a kernel from here, right? So yeah, that's done. So when you see the green tick here, that means the code execution got successful. Yeah, done. Now this will show, this should show the text box here. Yeah, it is here. Now we get something from the download. Let's use one of the code magazine that we have, and let's embed it. Okay, we got the error. So we forgot the colon here, right? So we'll continue from here. PDF chunks load in. So the error is the page object has no attribute of extract chunk, right? So we need to see the function load extract text. Maybe this is the error. So let's see it again. Yeah, that was the error. Now, as we have created the chunks, we have printed some of them here. So that's there, and now we need to embed all the text PDF chunks we got here. And so we run the model. It's embedding using the embedding model we have declared above, right? So the method is passed, and now we'll run the embedding. It will take some time depending on the number of chunks and the chunk size you have. Okay, we got an error. So chunks embedding is not defined. Okay, so I made a mistake, typo. We have to run it again. Okay, so we got the embedding successfully. Now we need to define the retrieval chunk function, and now we will test it with the test question. Okay, so we have got the error, right? So error is question embedding is not defined. So if here question embedding is here, and yeah, here you will have questions embedding. That's why I thought I think it's giving, yeah, it was giving error just because of that. So we have to run this function again. Now we will run it again. Oh, another error. So if we see found chunks not defined, another typo error. Yeah. So I've used found chunk instead of found chunks. Right? So run it. You have all the chunks here that we created, and we can see our retrieve relevant chunks is working perfectly. Now we gonna use the ask PDF function. So instead of just rendering the chunks, we will gonna ask the question to the LLM, and then we'll see, right? So again, typo, I missed a colon here, and run it again. The function is defined. Now I will ask the PDF with the question, right? So error. So error is so there is some error in here, maybe. So let's read the error first. Client.chase got an unexpected keyword argument message. So what was the variable name again? Let me think. I think oh yeah, they are array, so it will be messages. We'll run it again, and then this one. I think this is working now. Yeah. So when we ask the question, it returned the answer through the LLM Llama 3.23 billion parameter. Now this was the test, right? Now we need to ask. We should be able to interact with the with the chat UI, right? So another typo is here. We fix the typo. We run it again, and then it says placeholder. Okay, sorry. We need to use equal here, and okay, another typo. Ask button dot handle questions is not defined, right? So because H was capital up there, we'll make the H smaller, right? So I think another typo here. Yeah, I think that will fix the issue. No, I got an argument name. Okay, so let me see. So I think it will be names. Yeah. Okay. So the UI is not rendered. Why so? Yeah, it's here. So it took some time. Now, as we have the PDF, we can ask any questions. So let's say that PDF was all about the I think .NET Core .NET, so we can ask the question. There is some issue in the key in this observe, where this is accepting the keyword even without entering the enter keyword, right? So what is, okay, this is a huge issue now. 70% the continuous response is false. CONTINUOS CONTINUOUS. Okay, this is the right thing, I think. So we'll have the text box reader again. This was a typo, and because of that, whenever I'm typing keyword, it will syncing. Okay, we have the text box. So what is the latest version of .NET Core? So it is fixed, right? When we ask the question is went to the chat, and it will take some time depending on your GPU capacity, and we might receive answer anytime. Okay, let's run the code again. Let's see if it works. Again, maybe some syncing issue or something. So .NET version. So it should ask from the word, yeah. So the Llama 3.23 billion insert. The insert is stated according to excerpts. .NET 5, .NET Core next, and this is a simple latest version. And this is basically answering on the basis of the token number of prediction we have asked for, right? So that's there. So yeah, this is what we have come for here, and this is done. This is the core pattern behind most of the chat with your document system. Okay? So that's all for now. Thank you very much. We'll see you in the next session.